Hello Math 2 students, this is your lesson for 2.5.1. This is the notes and of course you're watching this on Edpuzzle, so you're getting credit for the classwork grade for Edpuzzle as well. I've decided to go back to the Smart Notes app to do the notes instead of opening Cami myself. The main reason is because as you'll be able to see when I point to something on here, like I'm pointing to quadratic function right here, and when I do that on Smart Notes you can actually see what I'm pointing to in the video, and when I do that on Cami you can't see what I'm pointing to. So a lot of times I'm talking about something in particular and I'll have to highlight it and say the purple part or the yellow part or whatever, and because you can't see what I'm pointing to. So I actually like this better and we'll probably just continue this for the rest of the semester. So we've been doing a lot of factoring quadratic equations, the x squared plus something x plus a constant. And when we factor those, what we're finding when we get x minus 3 and x plus 4, those give us the x-intercepts. So what that means is where that graph crosses or touches the x-axis is what that gives us. And we're going to start looking at the actual graphs today. So this is where your note starts, and okay, so the graph of a quadratic function, the equation looks like this. It's a times x squared plus b times x plus c, where a is our a, we call it our a value. That's the first coefficient. So it's a coefficient of x squared. Sometimes it's 1, sometimes it's not 1. Sometimes it's positive, sometimes it's negative. And then you've got your b here. This is another coefficient. So if I gave you the example x squared plus 2x minus 4. Remember when we did quadratic formula, the a value was right here, the b value is 2, and the c value is negative 4. So that's what we mean by ax squared plus bx plus c. That's just the form that it takes. Okay, and this is called the graph part is called a parabola. Okay, every parabola is U-shaped, so it would look, something like this. And it is a function. It does go out a little bit. Every one of them does, even though some of them look like they go straight up. So if the leading coefficient, in other words, the a value, so if the a value is positive, the parabola is going to look like this U right here. It's going to open up. For example, here is y equals 2x squared. The 2 is a positive number, so that means it opens up. So it looks like this, of course, which means the arrows are pointing up. But we also have this point right here, which is called the vertex. It's just like an angle vertex would be. And we say that this is the minimum. And we're going to talk some more about that in just a minute. But it's a minimum if it's at the bottom of the graph. That's kind of how I think of it, because something that would be a minimum would be at the bottom of something, would be the lowest point. Okay. If the leading coefficient a is negative, the parabola will open down. In other words, the arrows will point in a downward direction, and then you will have, this is still the vertex. The vertex would be called a max or a maximum in this case. So if the leading coefficient is negative, it has a maximum. If the leading coefficient is positive, it has a minimum. So the a value is leading coefficient. Let's look at these down here. This word should be or. Determine whether parabola opens up or down. Okay, so here we have a positive 3, so that means it opens up. And up is a positive direction if you think about it. Negative, oh, I'm sorry, let's go to B, sorry. The coefficient of the x squared term, the a value is 1, so that's a positive, and that would be up. C, the x, and always look for the x squared coefficient. Don't look for the other two. The x squared coefficient is negative 1, that one opens down. Over here we have a negative 8 as the x squared, that one opens down. Be careful on this one because you notice that your x squared term is actually in the middle right here. This one's positive, so it opens up. And then f, your x squared term is all the way over here on the end, and it's negative, so that one opens down. Okay, so we already actually talked about this on the previous page, but the vertex is the highest or the lowest point on a parabola. In Math 3, you're going to see this called a turning point, because graphs can have more than one turning point. You could have a graph that looked like this, and you would have 1, 2, 3, 4 turning points on that graph. So those aren't vertices really. A vertex is on a parabola, it just has one turning point, but you might see the word turning point in the future. I'm going to erase that part. I'm going to erase this graph. We're not looking at that type of graph today. We're only looking at parabola. If the parabola opens up, the vertex is a minimum, such as, just like we were talking about a while ago, there's the vertex right there. If the parabola opens down, the vertex is a maximum. And that would be illustrated. That's a terrible parabola, but that would be the maximum. So that would be that one, and that is that one. Identify the vertex of each parabola, then give the minimum or maximum value of the function. Okay, so this parabola opens down. In other words, the opening of it is pointing down. The arrows are pointing down. So this is a maximum. And this maximum is at 1, 2, 3, 4, 5, 1, 5. Okay, and that's where the vertex is. This is opening up, so this is a minimum down here. And the vertex is at -2, -1, 2, 3, 4, 5. -2, -5. Okay, so that's what the vertex is. It's where it turns. So it's going in one direction from left to right. It's going in one direction, and then it turns and goes the other way. That's what a turning point or a vertex is. The axis of symmetry. So the axis of symmetry on a parabola is always a vertical line. And I'm going to make this easy. I'm going to put it in more simple terms. A vertical line that cuts, this is so hard to write on, cuts the parabola in half. And I'll give you a hint. It's always the x value of the vertex. Okay, so my x value, or here's my vertex right here. My vertex is at 3, -8. The axis of symmetry, I'm going to say A of S, is x equals 3. It matches the x value. Okay, and we might draw like a dotted line showing the axis of symmetry. That cuts that parabola in half. If you like folded that parabola over, it would be over that line right there. If this was on a piece of paper and we wanted to fold it in half, that would be the crease. Okay, part B, the vertex is at 2, 0. And the axis of symmetry is at x equals 2. Right here, the vertex is at -1, 4. And the axis of symmetry is at x equals -1. That's how you state it. You say x equals, because it's the point where the axis of symmetry would cross the x-axis, right here at 3. This one would cross it at 2, and this one would cross it at -1. And that lines up with the vertex. So let's say you're not actually looking at the graph and you're looking at the equation like these down here, and you need to find the axis of symmetry. Well, there's a formula for that, and it's right here. X equals the opposite of B, so this is a sign change of B, over 2 times A. And remember, B is here and A is here. Okay, so if we wanted to find the axis of symmetry for A, for example, part A equals 1 and B equals 3. So we would plug it in to this formula. that would be negative 3 over 2 times 1, which is negative 3/2. This would be hard to see on a graph. I mean, if you looked at it on Desmos, it would give you negative 1.5. But if they want a fraction, then the best way to do this is to plug it into this formula. All right, let's look at this one. On B, A equals negative 3, B equals 10. And remember, A is the x squared term, the x squared coefficient. B is the x coefficient. So if I plug it into the formula, that would be the opposite of 10 over 2 times negative 3, which is negative 10 over negative 6. And then I would need to simplify that, divide by negative 2. That is going to be 5/3. And then the last one, A equals 2, B equals 4. So this would be the opposite of 4 over 2 times 2. That's negative 4 over 4, which equals negative 1. So that's the, and this is part of the quadratic formula. If you remember, on the quadratic formula, we have x equals the opposite of b, and then we've got that, the discriminant, the plus or minus and all that, and then over 2a. So that's actually part of the quadratic formula. So here again, if you only have the equation and you don't happen to have a graphing calculator and you don't have Desmos in front of you, and you need to find the vertex, you can do that. So the first thing we want to do is find the x value for the axis of symmetry, which is this formula up here. So, and then what we would do is substitute that in the actual equation. Okay, so let's look at this one. A equals 5, B equals negative 10. Okay, so the opposite of negative 10, which is 10, over 2 times 5, which is also 10, so that's 1. So x equals 1. Then what I do is I go back to the original formula and I plug in a 1 for x. Y equals 5 times 1 squared minus 10 times 1 plus 3. Okay, 5 times 1 squared is 5. Minus 10 is negative 5 plus 3, so y equals negative 2. So this is my x value. This is my y value. So my vertex would be 1, negative 2. Okay, and then this one, let's see, A equals negative 1, B equals negative 2. So the opposite of B is 2 over 2 times negative 1, that's negative 2. So my x value is negative 1, and then I go and plug that in. Y equals negative, the opposite of negative 1 squared minus 2 times negative 1. Okay, so we got to do order of operations, and you can put this in your calculator too. Negative 1 squared is 1, and then the opposite of that is negative 1. Negative 2 times negative 1 is, yeah, that would be minus negative 2, so plus 2. That equals positive 1. So that's my y value. So here's my x value, here's my y value, and that is my vertex, negative 1, 1. If we graphed it on Desmos, we could see it also. But sometimes you just don't have it in front of you and you need to know how to find it. Okay, so in Math 3, we do a lot of this. These are called key features. What that means is these are the things that we see when we look at the graph, okay? But this one, we're going to graph it by hand. We're going to find these things here with using the equation, and then we're going to graph it by hand. But a lot of times I will tell you, go graph this on Desmos and then look at the graph, and let's find these key features with the graph. In Math 3, we add several more key features than what you're looking at right here. I do want to add domain and range, and I'm just going to do a D and an R for domain and range, and we'll talk about what those mean in just a minute. Okay, to find x, let's use that formula. We have A equals 1, B equals negative 4, and C equals negative 5. The y-intercept is always C, so the y-intercept is going to be negative 5. All right, find x. The opposite of B, that's 4, over 2 times A, that's 2. So x is 2. Just want to check and make sure I got the right thing. Okay, so that is the x value in the vertex. Okay, y, find y. What I can do now is plug in the 2 up here. 2 squared is 4, minus 4 times 2, that's minus 8. So 4 minus 8 minus 5. That's going to be, 4 minus 8 is negative 4 minus 5, that's 9. So that is my y value of my vertex. Okay, actually, you know what I want to do? I want to erase this right here. I just want to write the negative 5. I don't want to write y equals negative 5. The y-intercept is negative 5. The x-intercepts, what we can do is we can actually factor this to find those. Let's look at the axis of symmetry first. Remember, I told you this always matches the x value in the vertex. So this would be x equals 2. Let's go ahead and graph the vertex. We have, oh, I'm sorry, this should be negative 9. I put a positive 9 there. Okay, so we have 2, negative 9. Let's graph 2, negative 9 right here. So there's the vertex. We also know that because the a value is positive, it's going to open up. So again, these are things that we just know about the graph and we observe about the graph. So we also know because it opens up that this is going to be a minimum, the vertex is. What this chart means, and the one over here too, is what you can do when you have a parabola, and like especially when you have a 1 for an a value, it's really easy. From the vertex, you can it's going to be 1, 2, 3 every time. And then this is going to be that number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And then from the vertex, that's what you're going to do. But the up and down, you need to know that if it opens up, you're going to be going up. Now, we can also find the x-intercepts and do it that way. But let me just show you what this means. Over means left or right. It actually means left and right. And then up or down, this one's going to be up because it opens up. Okay, so here's what we're going to do. From the vertex, we're going to go right 1, up 1. And then we're going to go left 1, up 1. And then go back to the vertex. Go right 2, up 1, 2, 3, 4, because it's 2 squared. Because the original equation was x squared, so this is going to be, so it's like this is x and this is x squared. Okay, and then we're going to go left 2, up 4. 1, 2, 3, 4. Okay, and then we're going to go right 3, up 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's my x-intercept right there. And then my other one, because my axis of symmetry is right here, I can count 1, 2, 3, 1, 2, 3. There's my other x-intercept right there. And then this is going to be really rough, but let's just try to kind of make a curve. The left side's always worse than the right side. So there's kind of what my parabola should look like. Okay, so my x-intercepts again were at -1 and 5. Okay, so let's look at this equation right here. Let's look at this and let's factor it. If we factored it, we would get x minus 5 and x plus 1. That means x equals 5 and x equals -1, setting those up equal to 0. So those are my x-intercepts. Domain, okay, so what domain means, let me put this over here. Domain, you want to look at the left and right movement, okay? Okay, so look at the arrows. Do they go forever in the left direction? Yep. This arrow goes forever in the left direction. It does not stop. Does it also go forever in the right direction? Yes, it does. Okay, so domain would be, this one goes towards -infinity on the left, and this one goes towards +infinity on the right. If it stopped or started somewhere, then that would be a number. It doesn't. It goes forever. And I'm going to give you a little hint too. The domain of a parabola is always the same. It's always, you can either write it -infinity to +infinity, or there's another way you can write it. You can write all real numbers, which is what that means. Okay, the range. So the range is the up and down movement. All right, so let's look at this. I always tell my students, start at the bottom. Okay, so look at the bottom line where the parabola stops, okay? And I'll give you a hint too. It's always going to be the y value in the vertex, okay? So we're always going to have a y, and then that y value, -9. It's either going to be greater than -9 or less than -9. So is that whole graph above the -9 or below the -9? Well, if it's above it, that's everything that's greater than or equal to -9. If it were below it, I would have put a less than or equal to here. There is another way we can write this. We can say, well, this graph at the bottom starts at -9, and at the top, it points in the upward direction forever. So that's positive infinity. So there's a couple of different ways you could write it. I really don't care which way you write it. I think that the y is greater than or equal to -9 is easier. Okay. Okay, so we have 2 more graphs on our notes, and I really, really want you guys to get used to using Desmos. It is a graphing calculator. It is so much easier to use than the handheld graphing calculators, in my opinion. So what I want you to do is go over to Chrome and type in desmos.com. And so yours is going to say something like start graphing. I'm already logged into mine. So mine just says my name here. Let me see if I can move this down a little bit. There we go. Okay. So we are going to go right here to this blank, and we're going to type in our next equation. You can type y equals. You can type f of x equals. It really doesn't matter. If you type y equals and then you start typing in your equation, that'll be fine. So we have a -x, so type -x. Okay, now to get that square in there, the exponent, because it was -x squared minus 2x plus 8. To get the squared in there, just hit Shift 6. Shift 6, and then there's your squared. Now hit the Tab key, okay? And then minus 2x, and then plus 8. Okay, so I do want you to notice that this thing is counting by 2s. Sometimes if you zoom out, and you can do that with 2 fingers. I'm holding 2 fingers on my mouse pad, and I'm zooming in and out. If you zoom out, it'll change. It'll be like that's 1 and that's 2, okay? But if you get really close in, it will do like, at some points, it won't show like the -1 and the +1. So I usually zoom out enough so I can see the vertex. Okay, so there are some points that you can touch on or you can hover over on Desmos, and it'll show you what they are. The x-intercepts, for example, I've got one right here. If I hover over it, it tells me it's -4, 0. Well, that means x equals -4. Okay, so I'm going to click on that though, and that way that point will stay there. Here's the other x-intercept right here, so click there, and that one will stay there also. Here's my vertex right here, and here is my y-intercept. Okay, so for me, I have a snipping tool, so I can take a picture of this. I think you can probably take some sort of a screenshot, but I have the snipping tool, so that means I can take a picture of this part right here, and then I don't even have to like save it or anything. I can go back over to my notes and click Control-V, and it actually just puts that picture on here for me, which I think is pretty great because it looks so much better than anything that I could graph over here. So then I just paste it right here. So if you want to do that on yours, you can. If you want to draw it by hand, you can. But if we're talking about key features, yeah, I kind of want you to know how to find them, like that symmetry. I want you to know what those formulas are, or at least be able to look them up. But if I'm talking about key features and I just want you to look at it and tell me what the key features are, usually I'm going to tell you, go graph it on Desmos. I need to move, well, see if I can move it from down here. Here we go. Get that back where it's supposed to be. Okay, I also am really weird about this, but I like to make sure I draw arrows at the end, because if there are no arrows down there, that means the graph stops. Okay, let's look at our things that we noted on here. So find x. Well, the vertex is up here. Here's the vertex. So I've got -1 and 9. Okay, so x is -1, y is 9 in the vertex. I don't need to do a formula if I can just look at it on Desmos. Do I have a maximum or a minimum? Well, this point right here is at the top of this graph, so that means that's a maximum. And it opens down, and we can see that because there was a negative x, yeah, it opens down. The axis of symmetry is always, always, always the x value in the vertex. X equals -1. And if I were to draw this dotted line, it would cross the x-axis at -1. The x-intercepts, I can see what they are. You can either write, you can write them as ordered pairs, or you can just write -4 and 2, but do not put it in parentheses, because if you put it in parentheses, that's an ordered pair, and that's wrong. The y-intercept is up here. It is at 0, 8. The domain, always the same for parabola. It's either all real numbers, or again, you can write -infinity to +infinity. I don't care which one of those you use. Range, okay, I want you to look for the y value in the vertex. It's going to be a y and then a 9, okay? So this whole graph, let me get a different color. Here is where the maximum is, okay? The whole graph falls underneath that yellow line. Under would be less than. I mean, think about it. If you are under 5 feet, you are less than 5 feet. So that's going to be a less than or equal to. And that's it. We don't even need this part because we're not trying to graph it. We went to Desmos and graphed it. We're also going to graph the next one on Desmos. And that's our last one. All right, let's see. I'm going to go back over to Desmos. And let me show you this. To see this red thing right here, if you click on that, it will make that part invisible, but you can still keep that equation in there, and then you can click right here and do your next graph. All right, so our last one is 2x squared. 2x, shift 6, 2, and then tab to bring it back down, plus 4x. Okay, let's find what we have here. Okay, and let me show you something else. If you can go back over here and make this one visible again too, and you can see the red and the blue. And we're going to be doing this a little bit later this week, when, either this week or next week when we look at inequalities. So anyway, make the red invisible. Bring this over here. Okay, so what do we have? We have the vertex right here. And again, I would suggest clicking on these so that they're visible and then taking the screenshot. Okay, so I'm going to take my snippet. Whoops, forgot to hit new. Try this again. One of my x-intercepts and my y-intercept is the same point, so that's why you don't see a separate y-intercept. Okay, so there's that. Then I can just close that out, go back over here, hit Control V, and it shows up. Make it a little bit smaller maybe. There we go. Okay. And then I have to put my arrows. It's just force of habit. Get this centered again too. All right, that's better. I'm kind of weird, but my arrows also have to match my graph, so I have to have blue arrows. Okay, so what do we need? The vertex. Let's do that first. Vertex is -1, -2. So what they're asking for up here is -1. What they're asking for here is -2. Just the x and y values. Okay, this thing opens up, so there is a minimum. The vertex is at the minimum at the bottom. The axis of symmetry matches the x value. X equals -1. The x-intercepts are here and here. Again, I would just write them as ordered pairs if I were you. I just think that it's easier. -2, 0, and 0, 0. Sometimes there's only one. Sometimes they're imaginary, and we did a little bit of that. But and if that happens, we'll go with quadratic formula to find what they are. Okay, the y-intercept is also right here, so that is also at 0, 0. The domain, all real numbers every time. The range, okay, let's look at where the graph stops. It stops right here. That is at -2. Again, that matches this number right here. So you're always going to have a y, and then you're going to have whatever that y value is, -2, If it's a minimum, it's greater than. If it's a maximum, it's less than. But just look at the yellow line and think to yourself, okay, that whole graph is above that yellow line. So that means that graph is greater than or equal to -2. And that's it. And that's the end of our notes, and we're right at 30 minutes.